Okay, we're continuing with the review for sections 3.1 to 3.3 and Algebra 2. And these are examples for your problems 23 through 28. Tough little section. You got a factor and there's a variety of problems in here. So I'm going to just take them one by one here. Okay, I may not take them in the order that they show up in. So for instance, this one here, we have a binomial with a minus sign in the middle, but you always look for a common factor first. So I'm going to look at this and take this x out of it. And when you take x out of it, you get x squared minus 36. At this point, I finally recognize that I'm dealing with a difference of two perfect squares. So those are really easy. They break down with a plus and a minus sign. And you take x times x to get your x squared, and you take 6 times 6 to get your 36. So let's see if it actually works here. You can do it two ways. One is multiply, and that gives x squared. The back gives negative 36. You may notice that there's no middle term, and that's because this 6x here on the inside and the minus 6 on the outside cancel off. And then once you're up here, you just multiply through by x to climb the ladder. The other way to do this is to store something for x, so I'll do that. I'm going to go 1.23 stored for x. The store key is down here. And then type the original. And compare that with the final result here. You should get matching answers. So that one is done correctly. Okay, now I'm going to switch gears and do this one that's got 4 terms in it. There's another one later that has 4 terms in it, and I'm going to do these two together here simply because they're the same type of problem. The dead giveaway is actually 4 terms. These are done by factoring by grouping. So I'm going to draw a line there and work on the first group and then later the back group. So what you're going to do here is take out the common factor here. In this case, it's 4x squared. And when you factor that out, you get x minus 3 here. In the back half, you always want to start with the sign that's immediately behind the dividing line. So I'm going to use a minus sign. And there is no common factor here other than negative 1, so you pull that out. And you can see that we have a common factor now of x minus 3, so you pull that out. And what you have left in the front when you pull the x minus 3 out is 4x squared. And what you have in the back when you pull out the x minus 3 is a minus 1. Now, a lot of people will stop there, but there is a difference of squares problem right here that mimics what happened on the back half of this one. So let's copy down our x minus 3 and set up that difference of squares there. It's going to be 2x plus 1 and 2x minus 1. Okay, all that remains is for us to check this. So I'm going to start by storing some number for x. I choose that one consistently. And type the original polynomial with 4 terms. And then this answer down here. And they should agree, and we're good. These are numerically equivalent. Okay, now I'm going to do this next one down here. It also has 4 terms in it, so that's kind of a dead giveaway for this type. All right, up front in the first group, this factoring by grouping here, we group the first two together, has a common factor of x squared. You always use a sign that's right behind that dividing bar, so I will copy that plus. And this one has a more visible common factor. It's 6. And we get x minus 3 when we factor out the 6. Well, now you can see there's a common factor of x minus 3, so you pull that out. And the factors that are left when you get rid of those x minus 3s are x squared plus 6. And this is can't be factored any further, so we're done with that problem. Okay, the next two problems I'm going to do are these two, and ultimately they involve either a sum of squares or a difference. Excuse me, a sum of cubes or a difference of cubes. Now I'm going to modify this one actually so that I can do one of each. Okay? So this one starts out with perfect cubes. This one's 7 times 7 times 7, and that one is 2x times 2x times 2x. And in order to see that, you can set up your calculator. You go to your y equals key, and once you're on the y equals key, type in x cubed. You can actually use the exponent key if you prefer it. But then you're going to go second, table settings, and set up your table. Then when you go to your table over here, you're going to see the perfect cube numbers on the right here. So for instance, 27 is 3 times 3 times 3. This one is 4 times 4 times 4, and you can scroll down and see more of them down below. But I'll point out that that 343 is on the list, and so is the number 8. Now what you want to do on these problems is write those quantities as perfect cubes. So you're going to use some cubes here. And this one is 2 and x times 2x times 2x, and the other one is 7 times 7 times 7. You'll remember that the 2 is across from the 8 and the 7 is across from the 343. Okay, then we use the formulas that we learned. These are called the SOAP formulas. You're going to learn it again here if you didn't the first time. So what you do is you write down your 2x and you square it. Your 7 and you square it. And then you multiply them together for the middle over here. You want to use the same sign as you started with, and then the opposite sign from that one. And at the back, you always use a positive. So there's your answer right there. So we're going to check it, and I'm simply going to quit to my home screen and store some number for x. You guessed it, 1.23. I'll type the original, and that gives me to type the final. We should get matching values, and it looks like we did. So I'll do another one like that. This one actually has a common factor hiding the fact that these are perfect cubes. And I get 1x cubed minus 125. And then I'm going to go back to my calculator, and I'm going to type in on the y equals line x times x times x and go back to my perfect cube list, and you can see that 1 is in that list, and we're going to need an x here too. And 125 is 5 times 5 times 5, so we're armed with what we need. Okay, so write down the 2, and then you need to write these as perfect cubes. One x times 1x times 1x, and then 5 times 5 times 5. So we're really close to having the right answer here. Let me set up a shorter parenthesis for a binomial, and then we have a longer parenthesis for a trinomial. And the signs go same sign, opposite sign, and then the back always positive. So you write down your 1x and you square it. You write down your 5 and you square that, and then you multiply them together for the middle. And that is the same as this. Let's see if we can show that by quitting to our home screen, typing in 1.23 or some other number that you choose, and typing the original. Once we have that, we type the other version of it down here. And you get matching values, so you know you did everything correctly. Okay? Last one here, and this is actually a much easier problem. We have perfect squares on the ends, and it's a trinomial. So this is probably, because of the perfect squares on the ends and the fact that it's a trinomial, it's probably a perfect square trinomial, so I'm just going to try it. You use the middle sign for both of them. Sometimes you have a negative there. 2x times 2x to get that. 9y and 9y to get the other. And then you have to check the middle term. We have an 18xy there and another 18xy there, so that worked. Now these can be written with an exponent instead. So here's the alternative answer. Okay, and that does it for problems 23 through 28.